I am for discipline. I am for clarity.
I have invented the word la ville radieuse, which cannot be translated in English.
He's usually quoted nearly everything that I've said, and not quite the way I said it.
Thanks very much to the Association for the invitation to speak here tonight. I'm going to, the bulk of the presentation will relate to the works that we've done on the East London marshes, but there's going to be two parts to the lecture. A short first part, titled Making Begins with Looking, and I'll show some material relating to the industrial landscapes of Shanghai and the Rainham estuary, China. A few years ago, I received funding for a photographic documentary project entitled Industrial Landscapes in Transition. It was really a self-set project, which is funded through NESTA, the National Endowment for Science and Technology in the UK. The project is about documenting urban change, the passage of vehicles, tankers and container ships, aggregates, bricks, trucks and workers at a scale which physicalizes the global flow of goods. At another scale of time, they represent shifting occupancies, states of dereliction, fallow land, development pressures from housing, new industry, and former public space. So this is my 5x4 traditional plate number. What follows are 5 photographs taken in Shanghai as part of this project, all based around the Huangpu River estuary. Shanghai was chosen as a site because of its key strategic position within Chinese and global trading networks. This image of Fuxing Island shows a range of small-scale workshops and warehouses, aggregate yards, and most prominently, the brick storage yard. The industries here are well established and predate recent economic explosion. The strip of water that forms the island is a canal. That forms the island in front of you is a canal created in the early years of the 20th century. So this is kind of the equivalent of the Dagenham of Shanghai. And geographically, it has the same relationship to the centre of Shanghai being to the east along the Huangpu estuary. This image is taken from the Lupu Bridge to the west of the main financial centre. The sites on either side of the river are those used for the 2010 Expo, but at the time of this photograph in 2006 were occupied by shipyards and former steelworks. This photograph records a condition which has now changed beyond all recognition and demonstrates most clearly the dynamic of the strategic relocation of large-scale industries downriver. So the pattern of the photographs is all taken from an elevated viewpoint, and they all use a lens shift to they really occupy a state that's somewhat that is panoramic and is tending towards an aerial viewpoint, but not literal aerials. So the places that they're taken from are all rooted in industrial structures and tall buildings. This photograph is taken from the Yangpu Bridge, overlooking the Shekou Road ferry terminal. The foreground shows a traditional topology of masonry sheds with tile and iron roofs, and a yard space occupied by a waste recycling business. Behind the container yard are brick and concrete frame warehouses dated from the early years of the 20th century. The boundary between low and high rise marks a point where the original port infrastructures along the river met with the agricultural land to the south. This companion photograph shows the northern street approach to the ferry. In the near foreground are a series of long, barn-like storage workshop buildings with brick load-bearing walls and masonry roofs. Their placement creates a sequence of courtyards off the street. Across the street are larger concrete-framed buildings structured around industrial courts. All of these buildings lie within the 1895 concession, meaning that these sites were originally developed under British jurisdiction. So there's a kind of there's a series of political territories that can be seen to influence urban development, and traces of that are visible in the present day condition of the urban structure. The last of the Shanghai images shows a semi-derelict wharf with an ageing collection of boats moored at the river edge. The derelict site in the foreground was used as a yard for bulk storage of waste paper. The wharf has since been replaced by a sports club. The Shanghai photographs document urban development with a history of 150 years at most. Recent change, post-1990s, is the most dramatically demonstrated. The purpose of the documentary is to register the scale and quality of change over time. This is a photograph from the same documentary series, but this one is the Thames, taken from the vantage point of the River Darren flood barrier. So it's taken from the south side of the River Thames, looking north, showing Rainham landfill, and on the horizon, the viaduct of the Eurostar line. The shipping containers are part of an extensive illegal settlement of Crayford marshes. The Thames is a kilometre wide at this point and fiercely tidal. Across the river, next to the landfill, lies Rainham marshes. So, at least in my own head, I see a lot of similarities between these kinds of contexts. The scales of development might be different. There might be a kind of time shift between the forms of settlement at the river edge, but there are lots of resonances between these different strange sort of river settled edge conditions. This map sets Rainham in the context of regional green space planning. Rainham is here at the knuckle point of the map. So we're talking about an area of marshland that's over 600 hectares in extent. The brown and dark green areas make up Greater London. So all of this taken together is Greater London, obviously with the Thames estuary. The dark green showing the scope of the East London Green Grid planning strategy. The lighter green swathes along the estuary to the north and south show the South Essex and Kent Townside green grids, and the yellow hatched area is covered by a planning initiative known as Thames Strategy East. So the marshes themselves are at this knuckle point of a whole series of initiatives, which means that in terms of attracting funding for projects, it was at that point in time really critically placed. So this is an aerial view of the Thames looking east, away from central London. Rainham marshes are to the left of the first big kink in the river. That's here. To the left can be seen housing from the interwar period. The line of the natural floodplain can be seen very clearly. It's really the boundary between the industrial settlement that appeared on the floodplain from the 1930s onwards here. So this is really the line of the end of the floodplain. The traditional condition of tidal flooding is now controlled by a hard river wall along this point. But traditionally all of this land flooded with brackish water. Another aerial view looking back to London, showing the western edge of Rainham Marsh and next to it Rainham Village. The drainage ditches in the foreground date from a period when this land was a salt marsh, subject to regular flooding from the Thames. Between the marsh and the river is a strip of active industry, including Tilda Rice and its old wharf, and in the bottom left corner you can see the tip of Rainham landfill. So this is a working wharf. These are the old patterns of drainage of the salt marsh, and some of these ditch structures are considered to date back at least until medieval times. This vertical aerial shot shows the Thames above Rainham. So we have the Royal Docks, so Rainham is here, the Royal Docks, the O2 Dome, Canary Wharf, with Rainham marshes to the right. To the north of the marshes is the landscape of gravel extraction and landfill sites here. So it's a kind of messed up agricultural land. Historically, the river was a route of exchange between the city and the landscapes to the east. Food and building materials would be carried upstream, and the same barges would return with the city's waste. This slide shows a scale comparison between Rainham marshes and a series of other London parks. The Rainham is at the top, and from left to right come the Barnes Wetland Centre, a nature reserve in West London run by the Wildfowl and Wetlands Trust. Next, Hyde Park and Kensington Gardens, and lastly, Hampstead Heath. So you can see that in landscape, just in area terms, it's a huge piece of land. Recognising Rainham's significance, just over 10 years ago, the Greater London Authority put in place a policy to develop the marshes as a new open space for London, combining landscape conservation with public access. This is a photograph of Dagenham Bridge from the 1890s, showing the pre-industrial condition of the marshes in the Thames floodplain. Dagenham Bridge, the water body you see on the photograph, had been formed by a catastrophic flooding event in the 18th century, which has scoured out a section of the alluvial moats. This landscape is now covered by the Ford diesel engine plant. The open marshes at Rainham remain as a memory of this relatively recently much wider open landscape. This photograph shows the wharf at Rainham Creek in the early years of the 20th century. You can see Rainham Village in the background, most prominently in the tower of the Norman Church. At this time, the creek was tidal, and boats carrying freight could navigate 3 kilometres from the Thames to the wharf. Typically, freight included timber, coal, and building stone. And the wharves were also used for local produce, fruit and vegetables travelling from market gardens into the City of London. This photograph probably dates from the 1970s, and it shows Jock Mill, who was the head shepherd on the marshes for over 40 years. During that period, the marshes were owned by the Ministry of Defence and used as rifle ranges. Even so, the land was still grazed, with herds of up to 1,000 sheep owned by the Smithfield Meat Company. The rifle range structures can be seen in silhouette at the top left of the image. The boundary between marshes and the neighbouring industrial development is very stark. This edge represents the boundary of the Inner Thames Marshes site of special scientific interest, the highest wildlife designation within UK planning rules. The marshes are home to a wide range of breeding birds, notably the lapwing, and are a nationally important habitat for the water vole. The ecology of the marshes works in tandem with that of the Thames foreshore. Wading birds are attracted to the foreshore moats by the presence of marine invertebrates, and there's an exchange in ecological terms between the habitats of the marshes and the habitats of the foreshore. This is a historical aerial photograph from the 1990s of the, so this is really the full 600 plus hectares of the site that we've been dealing with. So it includes portions of historic grazing marsh, which you can spot by the patterns of the sort of feathery patterns of the ditches and watercourses. Secondly, the silt lagoons, which are composed of material that's been dredged from the Thames. They're built over the ancient marshland, and they're created by an earth bank which forms a sort of perimeter enclosure, and then the dredgings themselves are pumped, mixed with brackish water, into this container. So they form a raised plateau above marsh level, which supports saline habitats that mimic the conditions of the foreshore, so they become wildlife habitats in themselves. Thirdly, the landfill, which is ongoing and due to complete in 2025, with a plan to restore it and eventually open it up to full public access. And then you have the settlements of Rainham Village and Herfleet forming entrance points to this, which through the course of the work began to be considered as a single space to be developed as a new conservation park for London. So in 2003, I was commissioned together with the German landscape architect Lantzen partner and a team of business planners and other consultants to develop a master plan for the marshes. The plan was based around conservation of historic and designated habitat, enhancement of the wildlife value of the marshes through management of water levels and vegetation, including the reintroduction of grazing to the site. Thirdly, enable and control public access, bearing in mind the potential negative impacts on public access to the wildlife. And lastly, considering modest elements of new built development, a kind of new visitor infrastructure for the site. This is a second visualisation from the master plan showing a public jetty and walkway on the Thames foreshore. The image shows a series of concrete barges which are relic structures dating from the Second World War, so those exist at this point on the site. We suggested a jetty linking across the foreshore to a new river bus dock as part of a programme of direct river access to the marshes from central London. And we also included an idea of a new small building, perhaps a smokehouse for river fish or some similar small-scale public programme. As part of the new visitor infrastructure for the site. So from the master plan, then incrementally, we moved into working on a series of small-scale built projects, which over time have started to take over work really across the whole of the marshes. So that's the current situation, is that we really created a series of projects that tackle a number of critical points across the whole of that 600 hectares. So the context for this work is that large parts of the site had been in the ownership of the Ministry of Defence from the early years of the 20th century up until the late 1990s. So meaning that for local people, opening the site up to public access was a big deal. This photograph shows new boardwalks at the Perfect Nature Reserve belonging to the Royal Society for the Protection of Birds on the eastern end of the site, giving public access to wet woodlands and grazing marsh. Here we see more boardwalks on the reserve, this time close to the Thames Wall. The boardwalks are integrated with new water management structures and elements of habitat creation to bring visitors into closer contact with wildlife. The new watercourse you can see to the left of the boardwalk is used as a seasonal water storage reservoir. These boardwalks are founded on driven timber piles, and handrails are provided only where there is deep water. This shows another new boardwalk at the western end of the marshes. This completes a public route through partially existing reed beds. Existing sections of open water have been extended through excavation to form new wetland scrapes. Here, steel is used for piling, main framing, and guardrails of the boardwalk. It's a more vulnerable environment with 24-hour public access. On the horizon, you can see the highway structures of the A13, signage and street lighting that from certain locations can be read as parts of the same infrastructural language as the boardwalks. So we're deliberately taking on that similar language of those more conventional infrastructural engineering, infrastructural elements. Treated timber piles, the same as those used for the timber boardwalk construction, are here used as foundations for a small group of public and educational buildings on the Purfleet Nature Reserve. As with the boardwalks, new construction is linked to the creation of new wetland areas, open water, reed beds and screening banks. So phase one of the project was establishing the landscape setting. So these are all new sections, these are new embankments, new sections of open water. And then the building project is the phase two, which occurred after a couple of seasons after the landscape elements had matured. This photograph shows one of the new buildings founded on timber piles. The building's shells are formed from reclaimed international shipping containers. So, originally made in a steel yard in China, the containers have been sandblasted to remove all paint finishes and reveal the Corten weathering steel beneath. On the horizon is an electricity transformer on a timber post. We really like the directness of these kind of structures and hope that the new buildings have something of that quality. Another view of the same complex showing the integration of buildings with boardwalks and open decking. The pattern of boardwalk construction here is the same as that used on other parts of the reserve. We wanted these decks to read as a natural extension of the same path network. While some of the details of the containers have been left as found, we added doors and shuttered openings which were fabricated in Corten steel with an intention to suppress any clear distinction between found and new construction. This plan shows how three discrete building volumes create a loose, water-filled courtyard. So these are the three building volumes, and then the rest of these areas are open timber decks. So here is the main boardwalk approach. Then you come through an earthwork berm through into this cluster of buildings and marsh. The Thames is over here, and the marsh extends to the north and to the east. So here we see the areas available to general public access. So that's on this side. So you come, if you're a member of the public, you come through here, and there's an open deck, and then this public room here with a view out over the new wetland and onto the marshes. And here is the area, on this side is the area reserved for school groups with a small classroom opening onto an outdoor teaching area. Looking from the back of the classroom back towards the public areas, here you can see two different opening treatments. Firstly, one of the large new door openings trimmed with a Corten steel band. So that's this one here. The door leaf is also formed from Corten steel with stiffening plates. Secondly, you can see the narrower trimmed openings with plain timber shutters and no glazing. So that's this order of opening. The water levels here vary seasonally and have been managed so as to allow reed growth within the courtyard. So reeds depend on a certain depth of water, which we've worked to manage and manipulate through earth moving and management of water levels to be a kind of optimum depth for reed growth. This shows the public deck and screening. The main purpose is to allow views through to the wetland habitats and open marsh beyond, while screening wildlife from disturbance. The close spacing of the timbers allowed us to eliminate any other form of guardrail. The deck is ramped down to enhance proximity with the water. And there is considerable seasonal change within the landscape elements coming from fluctuating water levels and reed heights. So working with these very sort of shallow horizon levels of ground and vision. Another view of the public deck showing the gentle ramp and relationship to the public outlet room. So in the first image you saw the main container doors were left on. Here the container doors are removed to form a larger opening. can see how the public outlet room is formed from two containers side by side. Sitting across both containers is a plywood deck with conventional membrane roof ventilated below. The timber deck in this photograph is hidden by a new quartet steel trim. And then just peeking up over the top are the white line shows a series of oyster shells which were used as ballast on the roof. An interior view of the public outlet room. So from inside there is no clear registration of the two volumes of the clay containers. The timber column is actually structural. It's used in the rawest state possible with the bark on. It allows best use of limited headroom within the containers and the elimination of any downstand beam. Note the scale of the glazed opening to the left. The character of openings to this side contrasts markedly with the blankness of the back facing into the cluster. This shows the classroom and the teaching field in front. Here you get a good view of one of the larger openings. We used a folded, fabricated quartet steel beam to trim the as-found corrugated shell of the containers. The beam itself forming a weathering hood to the opening. The character of the building cluster changes markedly when seen from different orientations. This view is from the north with the Thames and the seawall in the back. So we're probably about 50 metres from the Thames on the far side of the seawall. At a different scale, an outlook point 10 metres above original marsh level, set up on the edge of a 1930s landfill, composed mainly of ash and building waste from central London. Benches of two kinds use folded quartet steel frames with reclaimed oak timbers. The paving is formed from reclaimed concrete railway sleepers, taking the same, so the timber and the concrete take the same dimensional scale. A carpet, a chair and a table, basic elements of a room, but using a material vocabulary at once monumental and raw. Another example of paving used together with naturally colonising vegetation. This example is from the teaching area next to the classroom that I've just shown. In this case, we made new precast units, concrete units, paired and laid with minimal gaps to form a vegetated ramp accessible by wheelchair users. The concrete railway sleepers we used elsewhere are really, they cost nothing. A lorry load costs 600 quid. They're more rough and ready, but they represent pretty much nil embodied energy. So we've used them fairly extensively for trafficked areas on other parts of the site. This is another example of a quite rest area. This one on the western marshes, again 24-hour accessible. This part of the marsh was used as a construction compound for High Speed 1, the Eurostar line. It was full of construction huts. When construction work was completed, Natural England suggested leaving the hardcore base for the compound to develop as a brownfield habitat. So the ground condition that we see here is built up of firstly marsh alluvium, over which is spread at Natural England's behest hardcore from the construction compound. And on top of that, reclaimed concrete railway sleepers introduced by us, colonising vegetation, which is an as-found condition, and lastly, two benches made of Portland stone, which are the size of double beds. One of the most significant of the landscape infrastructure elements on the marshes are the bridges. For this first suite of 6 bridges, we used quartet steel to create 5 frame-like structures that have a visual transparency both in elevation and in plan. The guardrails have a cone-like structure, a relatively high 1.4 metres to meet the required specification for cyclists. And you can also see the use on those drawings of timber decking with exaggerated gaps to allow an awareness of the water beneath the bridge when crossing. This is a view from the steel fabricators workshop just outside Nottingham, showing the fabrication of 2 of the 17-metre beams. Seeing these things inside gives you a different perception of scale than when they're out in the open landscape. Corten steel plate is easy to get hold of, but structural sections of corten are very difficult to get hold of. So pretty much the whole of the bridge is cut from 25mm corten steel plate, including 25 by 25mm square sections that we specify for the handrails. The new bridges relate to new public access infrastructure. They cross both existing and new watercourses. When we were designing these, we anticipated a kit of components that would be assembled on site. So we were kind of amazed when 6 trucks arrived on site, all on the same day, each one with a finished bridge. This is the 17-metre bridge being installed. The bridge crosses a new watercourse, which was itself required as a buffer between a new foot and cycle access path and adjacent sensitive grazing marsh habitat. The view is taken from the Silver Lagoons, looking west, which gives you the elevation of the view, and you can see along the whole length of the new watercourse. You should note that the new bridge overshoots the water by several metres each side, allowing for habitat links between adjacent sections of the banks of the new watercourse. So there's a temporary sort of access structure running across the watercourse at this point, but that gets removed. What you need to do is make sure that there are continuous banks along all of the edge of all the watercourses that aren't interrupted by the bridge abutments in any way. Here you can see the bridge in relation to the new path construction behind the Silver Lagoons. You can see that the bridges are set relatively high in the landscape with a ramped path approach. So what we couldn't do is actually get the bridge dead on marsh level. And that followed that this raising of the bridge deck follows on from the need to create a continuous habitat corridor along sections of the new bank. Initially, we considered this additional height. It's about 300 or 400 millimetres. A problem in that the bridges become exaggerated as objects within the landscape. But it actually works quite well because it gives the bridges themselves a quality of an elevated viewpoint within the landscape. The handrail guarding is formed from these 25 by 25mm square section steel bars in a feathered cone formation, which has a subtle visual effect, a kind of tripsy moire, which, when registered by the viewer as they move through the landscape, this kind of juggling, slight visual juggling as these layers of railings overlap on each other. So the design intent was to find a form of distinct figuration, but also to retain a sense of the new structures as relatively mute objects within the landscape. A second suite of bridges, 4 in total, were installed along secondary public access routes. We chose to make these quite different in character. These are precast concrete with hybrid timber and galvanised steel handrails. The timber, which is oak, is bolted onto the precast concrete, and then galvanised steel is screw bolted into the timber. So it's kind of an upside down form of construction with a reversed hierarchy. 3 different materials are used, which is chosen deliberately to weather to the same visual tonality, which is much more marked since this photograph was taken. So everything turns into misty grayness. This shows how the path construction, a compacted fill, is taken right over the bridges. This is in deliberate contrast to the visually transparent decks of the Corten bridges shown earlier. On one of the bridges, this surface forms a farm track used by vehicles transporting cattle to and from the site, so it becomes a literal road. These bridge decks have been detailed so as to allow vegetation to grow over to form a mossy or grass path, managed principally by the traffic and visitors. This view shows the general path condition, a compacted fill path allowed to grass over. the verges are streamed once or twice a year. That same bridge that we've just seen can be seen in the background, along with a vast wooden acoustic wall of the high-speed 1 Eurostar line and the ever-present electrical pylons. Here is another kind of path crossing of a watercourse, a bridge of sorts, although it doesn't look like a bridge. The photograph is taken from one of the public paths on the northern marsh, looking along one of the original salt marsh ditches. The ditch passes below the path in a large concrete pipe trimmed with a gabion wall structure. The pipe is big enough to create a wildlife corridor. The steel railing is a standard estate fence pattern which we've used along with other standard agricultural items around this part of the marsh to form the farm, some of the farm management infrastructure, overlapping with the visitor access. This is an aerial visualization of the trackway, which is the biggest of our bridges at Rainham. So this is the trackway. Changed a little bit since this design stage. So this is the bulk of the marshes is here. Thames is sort of from here is 3 kilometres in this direction. This is Rainham village with the Norman church. There's an 18th century merchant's house that was built by the guy who set up the wharf on Rainham Creek here. So this what this trackway does is tries to improve the condition of this bridge crossing of this thing, which is the Eurostar line. So the link between the village and the marshes was first that link was first severed with the construction of the Fenchurch to Southend commuter line in the 19th century. So that's this commuter rail line here. Which used to have a level crossing. This was then compounded with the construction of High Speed 1, the Eurostar line, 10 years ago. Here you can see the main bridge span of 120 metres, this thing, which is an approach ramp to this structure, with an 80-metre earthwork ramp, which runs down here. So it's really half of a project. It's clearly a sort of second half of the project, which is about how you connect this side of the high-speed 1 bridge into Rainham village. This, incidentally, is the site of a new library, which is just near the end of construction by Queen of Lavington. So it kind of works as a whole concept together with potentially a new station here, and then this link through to the marshes. This is an early visualization showing the idea of the bridge structure and its undercroft. The creation of new wetlands beneath the bridge effectively brings the marshes closer to the village. We worked with the structural engineers Jane Wernick Associates on the structural programme for the bridge. We wanted to make something that had a presence and character, but also had a kind of reticence to it. The construction uses a combination of timber in a pretty raw form, with a stiff composite steel and concrete deck. The canting of the timber columns creates natural bracing. This is an early study model which gives a good idea of the scale. The bridge has a gentle ramp around 1 in 28. This gradient is established by emergency routes that have to be spanned, together with the level of the existing high-speed 1 crossing. The structure looks irregular, but in fact there is a simple pattern to the setting out of the timber members. They are, in fact, on a kind of grid. This is the same model showing the whole of the bridge superstructure. The spanning portion has 44 timber columns, and the earth embankment sits up against here with the high-speed 1 bridge structure at this end. The bridge crosses 2 watercourses and a road to land visitors directly on the edge of the marsh, and it allows for the demolition of substantial parts of the existing high-speed 1 concrete structure. So these are the same elements in plan with the village up here. These are a series of watercourses, the main road, and then this thing, landing on a big earth embankment on the edge of the marshes at this point here. So it's really about marking a desire line in this gentle gradient that takes you right from this end of the bridge down onto the marshes. Here you see the existing high-speed 1 ramp and stair structure. Under the ground there's a whole series of high-pressure gas mains. We had munitions experts on site because this is an area that was subject to a lot of aerial bombardment in the Second World War, which conditioned the kind of piling that we used in combination with the high-pressure gas mains. So the foundations there's a whole series of concrete piles with a capping plate, from which then a series of concrete stud columns rise to take the base of the timber columns. So these are angled, so the tension and pressure of the columns is taken along the axis of the column. This is part of the superstructure. It's a galvanized steel ladder which is fabricated in 12-meter sections. Initially, it gets propped on a steel scaffold structure, and then there are precast concrete units dropped in, and then there's an in-situ concrete plate which is cast over the top of the precast unit. This is another view of the prop structure before the timber columns are offered up, and it shows how the ladder sets up a grid of nodes for the column heads. So the columns always come into the nodes here. You can see in the background, this is refurbishment of an industrial building by Alison Brooks Associates. Timber columns. We worked with a timber engineer in Germany called Peter Bircher, who previously worked with Jane Werner. His company supplied the timber columns and fabricated the nodes. The main contractor for the structure was Fitzpatrick's. So the principle of the node is that, a cast steel pin drops into a hole which is drilled into the centre of the column from each end. And then a series of stainless steel pins which run through transversely across the columns lock the cast steel element in position. And then the joints have to incorporate a spherical bearing, which is this thing, to allow them to take pin rotation both at the top and at the base. So this is Boris Johnson, Mayor of London. He was one of the first visitors to the trackway before the temporary props had been struck. So this image shows the top end where the trackway joins the high-speed 1 structure. So the columns, one of the elements of the design, because we had to design a structure which could be adopted by the borough highways authorities, it has to have a 120-year service life. So we argued that if there were any failure in one individual timber column through decay, the individual columns could be replaced with just by minimal temporary propping of the structure on either side. So the pin joints allow for a column to be removed and then replaced. And we also did, we had to have a whole series of arguments, reports about sort of fire damaged vehicles crashing into this. Anyway, we passed all the hurdles. So the concrete slab was cast and allowed to cure before the timber columns were loaded up. So once the slab is cast, the sequence is that the cast units are set in place, the slab is cast, then allowed to cure, and then these temporary metal structures are removed, and then finally the loading is taken directly on the timber. So this is a general view once the temporary propping has been struck. The idea of the guard railing is that it's a very transparent structure. We didn't want any structure happening above deck level. and there are still further opportunities. We did some excavation to create wetland beneath the structure, but there are still further opportunities for excavation around. The structure allows for further excavation and wetland creation at a later date underneath the structure itself. So this shows something of the sort of extension of the existing water course. There's the potential for further extension of these wetlands in this direction underneath the structure. There's also a future opportunity to close this road, which is no longer required. And what we'd like to do is turn that back to something much more like an agricultural track. So the material character of the structure really uses the raw timber, but it also picks up on elements. This is a high pressure gas main compound, which is going to be there for forever until the gas runs out. We've got two sets of pylon and electricity lines that cross directly over the top of this structure. Through the extensive use of the galvanized steel, we've got this sort of material affinity between our new structure and this system. This is the final view showing how the placement of the columns negotiates the spans of the watercourse roadway and high pressure gas main. So you get this kind of clustering of the structure because of the fact that it's spanning these various other elements. Another part of the public access programme is a suite of signage which was designed in collaboration with the graphic designer's studio Fred, who designed a bespoke typeface for us. We wanted to create something that would be there for 100 years plus. So we used water jet cut 12mm Corten steel plate folded to form like the supporting posts and the blades of these finger post signs. So this signage is a part of a suite that covers 9 kilometres of new public footpath and cycle path access, cycle access paths across the whole of the marshes. And then there are other elements to that suite of signage elements, including information boards. But I just wanted to cross the river. We've also done some work on the south side of the river, on the equivalent marshes to the south in Bexley and Erith. This sign is part of a wider signage project which we developed in collaboration with the same graphic designer Studio Fred and the writer Sarah Butler. The writing on these, the scale of disc is normally used for wayfinding, but we kind of mimicked it. So it includes new writing which is transcribed from collected local stories set onto a series of these discs which are strung out along a path across the marshes. So they form a kind of narrative. We make a wheelbarrow from the springs of a pram, wait for an onshore wind, hunt firewood. So this is the kind of gateway sign to the marsh. So this shows you an informal bridge which is made by the grazier who occupies this part of the marshes. The landscape's full of details like this. But the building behind is a new stable building that we designed on the Crossness Nature Reserve. The grazing of the marshes by livestock is an important part of management for biodiversity. Keeping the grass levels low is important for a kind of mix of invertebrates and bird species. So the creation of a new stable building is made to support the wider ecological programme for the landscape. Here you see the wind turbines on the Thames Water Nature Reserve. They don't generate electricity, but they actually draw water up above the water table to create wetland conditions on the marsh. The building itself is 100 feet long and sits as low as possible within the landscape. This view shows the building from the main access road to the reserve and shows how in summer months it's heavily screened by common reed found in the marsh drainage ditches. The roof and walls are in the same material, unfinished fibre cement sheet, but the profile is varied between the walls and the roof, since the roof has different spanning and loading requirements. The cladding panels don't form a closed construction. They're hung against the building frame with open joints. The building is unheated. Its main environmental requirement is to keep the horses dry. The emphasis is in creating free ventilation and avoiding any build-up of heat, especially in the summer months. A simple rainwater butt provides a local source of water in the summer months when ditches are dry. This is the other side of the building, this one facing away from the main access road. This view shows the stables in relation to one of the large industrial sheds that fringe the marsh. The new building uses a largely industrial material palette, but with a local response to scale and orientation within the open marsh landscape. The building uses a cold-rolled steel frame and joists, and the timber we've used here is sweet chestnut, which is sourced from Kent and is in plentiful supply. So, in conclusion, the work we've made at Rainham has run in parallel with a series of strategic planning studies, industrial master plans for the London Development Agency, and working collaboratively with other architecture and landscape practices on the East London Green Grid, a green space strategy across East London, which is now being written into the London Plan. We're currently working on a strategic plan for the Thames Chase Forest, which covers an area of gravel pits and emerging woodlands to the north of Rainham marshes. This allows us to expand the global scope of our work, the geographical scope of our work, whilst building on the local knowledge and contacts that we've developed over the past years. Latz & Partners project with the German landscape architects for the former steelworks site in Duisburg North was a 15-year project as a project on site. The work on the marshes remains unfinished, and the plan is to continue to develop the projects here. So this extended timescale of the project feels to me like a luxury rather than a frustration. I hope this presentation has explained something of the thinking that's gone into these projects, and I hope it can contribute to a wider discourse around the nature of the contemporary urban park.